So this is the single line diagram for the question given for us. Okay. So the question has one generator, one transformer, one transmission line and the second transformer and two motors. So our system has one generator which is supplying two motors through a transmission line which has a transformer on sending end and a transformer on receiving end. So the data written in the white color represents the given data which is otherwise known as your old data. So for if you consider generator, it is rated with 300 MVA, 20 kV and the reactance is 20%. And then for transformer 1, it is 3-phase transformer, 350 MVA, 20 bar 220 kV. Similarly, the transmission line is 0.5 ohm per kilometer. For T2, it is 3 single phase transformer with 100 MVA with voltage rating 127 bar 13.2 kV with reactance 10%. Similarly, we have the rating of M1 as 200, 13.2 and 20 and M2 as 100, 13.2 and 20. So, this is the data given in the question. Next, we have to draw the reactance diagram for the given single line diagram. This is the aim of the problem. So, now before starting to draw the reactance diagram, we should find what are all the base values given in the question. So, we have to find the base values for calculating the reactance of the entire component. So, the given base value is 300 MVA and 20 kV. Now, we know that we have to replace the reactance, each and every component with reactance component to find the reactance diagram. So, for generator 1, I have EG and XG. For transformer 1, XTF1 is the reactance we have to include. For transmission line, I am including XTL. For transformer 2, I am including XTF2. Then motor, I have to represent with XM1 and EM1. Similarly, for motor 2, XM2 and EM2. So, after drawing this reactance diagram, we have to find the per unit value of this EG, XG, XTF1, XTL, XTF2, XM1 and XM2. Similarly, EM1 and EM2. So, let's start with generator. So, per unit value of generator. So, we already know the formula to calculate per unit for a generator, which is Z per unit new is equal to Z per unit old into KVB old divided by KVB new the whole square into MVAB new divided by MVAB old. So, here the first component is Z per unit old, which we have to take from the given question. So, here X is 20%. So, 20% I am drawing it as 0.2 into KVB old is which is given in the question, which is 20 kVA. So, divided by KVB new is what is the new value given as a base one. So, 20 into, so MVAB new is 300 MVA and MVAB old is already given 300 MVA. So, if you substitute these things, we have Z per unit is equal to 0.2. So, if you see here, this generator 1 is taken as base value. So, this G1, that is why the actual value given is 20%. We have calculated is also 20%. So, if we take a base value equipment, the reactance will be same as the actual value. You can directly write it as 0.2 since it is a base, it is not a wrong thing. Then, I have written this 0.2 here 0.2 as my XG. Now, we have to calculate your EG. So, what is the formula for per unit value? E per unit is equal to actual by base, we already know. So, E is equal to V. So, actual value of voltage is 20 kV, it is given here. So, I have substituted divided by V base is 20 kV. So, 20 by 20 is 1 per unit. So this Eg value I have written here as 1 per unit. So I have completed the generated part. Next I have to move on to the transformer 1. So per unit value of transformer 1, the same formula which we have used here. So per unit old into kVb old by new the whole square, MVAB new by old. Okay. So per unit old is equal to 0.1. If you see here, 10% is the value given. So it is 0.1 into kVb old. So kVb old means we have to consider the transformer voltage value, which is 20 kV on primary side. So I have taken 20. Then kVb new, the same base value given here, 20 by 20 into MVAB new is 300 MVA, which is given as base, and old value is 350 MVA, which is given in the transformer. So I have substituted, and the transformer reactance value is 0.0875. So which we have to represent in the reactance diagram. Then we have to go for your transmission line XTL. So transmission line here per unit. So the formula for calculating the per unit value of transmission line differs from transformer and generator. It is actual by base. So actual value is, it is given as 0.5 per kilometer, 0.5 ohm per kilometer. Actual length of the line is 64 kilometer given in the question. So you have to multiply this 0.5 into 64, which is equal to 32. So we have calculated the actual value. The formula for calculating your base value is kVb new the whole square divided by MVAB new. So now if you see the transmission line kVb voltage, so it is the voltage which refers to the secondary side of transformer 1, which is otherwise known as HT side of transformer 1. So there is a formula to calculate the base on HT side of a transformer, which is kV base on LT side into HT rating divided by LT rating. So if you see here, the base kV on LT side is 20. So I have written here into HT rating of the transformer is 230 divided by LT rating, which is 20. So if you substitute here, I will be getting the value of 230 kV. So this is the base kV on this transmission line. So you have to substitute this 230 kV square divided by MVA new. MVA new is nothing but the base value given. So it is 230 square divided by 300, which is 170.32 ohm. So now we know that formula is actual by base value. So if you substitute actual by base value, I can got this value. So we have to substitute the 0.181 here in transmission line. Next we have to move to the transformer 2. If you see here in the question, it is given as 3 single phase transformer and the connection is star and delta. So first thing, we have to convert this 3 single phase transformer to 3 phase transformer ratings. Okay. So for that we have to change this voltage levels. So here if you see, the given rating is 127 bar 13.2 kV star and delta. So we know that if star connection, VL equal to root 3 V phase. So if you substitute and find the line voltage of 3 phase transformer is 220 kV, and since the secondary is delta, the voltage remains same, it is 13.2 kV. So I have transformed this 3 single phase transformer to 3 phase transformer with voltage rating 220 bar 13.2 kV. Similarly, I have to transfer this 100 MVA. So if I multiply this with 3, so I will be having 3000 MVA, sorry 300 MVA. So this is the rating of a 3 phase transformer. So 3 single phase transformer is converted to 3 phase transformer, 300 MVA 220 bar 132 kV. So now we know that the base kV on left hand side, that this one is 230 kV. I have to calculate the base kV on secondary side of the transformer. Secondary side means LT side. So the formula for calculating base kV on LT side is kVB old on HT side into LT rating divided by HT rating. So which is equal to 230. This 230 is what we have calculated here. This 230 into 13.2 is LT given here, or what we have calculated as 3 phase. So 13.2 divided by the converted HT is 220. So I am substituting here 220. So this is the base kV on LT side of the transformer. You have to write here as 13.8 kV, which we are going to use for the calculation of M1 and M2, which we will see in the further.